In this video, we're going to look at converting mixed numbers into improper fractions. In question 1, we're looking at 2 and 1/3. I can shade in 2 and 1/3 on this diagram as follows. Here you can see I've shaded in 2 wholes and 1/3. You can count that there are 1, 2, 3, 4, 5, 6, 7 thirds shaded in altogether. So 2 and 1/3 is 7 thirds. Ideally, it would be good if we could get this answer without having to draw out a diagram like this, and we can. What we need to do is spot that we are dealing with thirds, that's the denominator of this fraction here, and think about how many thirds there are in the 2 wholes. There are 3/3 in this whole, 3/3 in this whole, and then we've still got the 1/3 to add on at the end. So we can think of 2 and 1/3 as 3/3 plus 3/3 plus 1/3. Now, you might not have done adding fractions already, but hopefully it makes sense that when you are adding a load of thirds together, all we're doing is adding these numerators. We've got 3/3, 3/3, and another 1/3. That makes 7 thirds here altogether. Thinking of your mixed number in this way can save you time compared to drawing out a diagram. There is an even faster way to convert from a mixed number to an improper fraction, and we'll see that when we get to example 3. Let's look at question 2 next, however. In this case, we've got 1 and 3/5. So I know that this is going to involve an answer that is something over 5. The 1 whole is worth 5/5. And the 3/5 is just 3/5. So what I need to do is add those together. And I think of these as 5/5 plus another 3/5. That makes 8/5 altogether. So 1 and 3/5 is equal to 8/5 as an improper fraction. In question 3, we have 4 and 5/7. So there are 4 wholes, and each whole is 7/7. So this is going to be 7/7 plus 7/7 plus 7/7 plus another 7/7. That's the 4 wholes. And then we've still got to add on the 5/7. So we'll add that on. And if we've got 7/7 and another 7 and another 7 and another 7, that's 28/7 so far, plus another 5 more, that makes 33/7. Now that was quite a lot of writing and quite a lot of work. Hopefully you've spotted a shortcut that we could have used. Instead of adding 7/7 plus 7/7 plus 7/7 plus 7/7, we could have multiplied 7/7 by 4. We've got 4 lots of 7/7, which means we would have 28/7. So all of that would be 28/7 without having to add them up separately. We're just going to do 4 times 7 to get the 28 as our numerator. So we have 28/7 plus 5/7. And this technique will save us time when you're dealing with bigger numbers like we've got in question 4. In question 4 then, we've got 12 and 6/11. Now, we're dealing with 11ths, so we're going to think of a whole as 11/11. And in this question, there are 12 wholes, so we need 12 lots of that. And then we've still got the 6/11 as well, so we need to add on 6/11. Going for the answer then, we've got 12 lots of 11/11. 12 times 11 is 132, so that is 132/11 plus 6 more 11ths here. Now, again, even though you might not have done adding fractions already, hopefully you would agree that if you've got 132/11ths and you add on 6 more 11ths, that's going to get you 138/11ths. And this technique works in every question we've done. Here we've done 11 times 12 plus 6 to get the numerator. Back to question 1, we did 3 times 2, which is 6, plus 1 gives you the 7, the numerator of your improper fraction. In question 2, we could have done 5 times 1, which is 5, plus the 3 to get 8, and that would be the numerator of our improper fraction. And the reason that works is that when you multiply the denominator by the whole number, that tells you how many, in this case, fifths you would need in all of these wholes. In question 3, 7 times 4 gave you 28. That is how many sevenths you had in the 4 wholes. And then all you had to do was add on this 5 to account for the extra 5 sevenths. So 28 sevenths plus 5 more sevenths made 33 sevenths.